Hi everyone. So today we're going to go over implicit differentiation. So this is an FRQ that you could get on the AP exam, and it was on your mock exam as question number 6. So if they give you a curve, right, like it says here, consider the curve given by y squared equals 2 plus xy, and then it says show that dy dx equals y over 2y minus x. So this is telling you that they want you to take the derivative with respect to x of both sides of the equation and solve for dy dx. So how do I know that they want to take the derivative with respect to x and not y? Well, if you look at the bottom of your fraction, if you look at the bottom of dy dx, the variable in the denominator is x, right? So that's why we're going to take the derivative with respect to x of both sides. Okay, so it is important that you look at this variable here, and then you can see that that's how we're going to set up a. So we're going to go d dx on both sides, y squared is equal to d dx of 2 plus xy. Okay, and so just to recall this, right, when the variables don't match, right, and it's not a constant, we know that we're going to use chain rule, right, whereas these variables are matching and these ones aren't matching, right? Okay, so this is going to be 2y, right, because I'm going to use power rule, but then times the derivative of the inside, and the inside is y, so the derivative of y with respect to x is dy dx, equals the derivative with respect to x of 2 plus the derivative with respect to x of xy. Okay, so I have 2y dy dx equals, now the derivative of a constant is just 0, right? Remember, this isn't a constant times a function, it's just a constant by itself, plus, and now be careful here, because here we have a product of two functions, we're multiplying, right? Two functions together, so we've got to use product rule. Okay, so that means that we're going to do the derivative of the first times the second plus copy the first times the derivative of the second. Oops. Okay, so I'm getting that this is 2y dy dx is equal to 0 plus 1 times y plus x times dy dx. Okay, and again, because these don't match, so that means not the derivative isn't 1, the derivative is dy dx, and this means that because they match, the derivative of x is just 1. Okay. So now I want to get all the terms with dy dx onto one side of the equation, right? So here's my terms with dy dx in them. Okay, so I'm just going to move this over to the left-hand side and then leave the 0 plus 1 times y, in other words, just y on the right-hand side. So let's subtract x dy dx minus x dy dx. So I get that this is 2y dy dx minus x dy dx is equal to y, because if I simplify 0 plus 1, y. And now I'm going to factor out the dy dx. Okay, so because they both have that in common, right, that's their greatest common factor, but I'm also trying to solve for dy dx, so I have to get it by itself by factoring out the dy dx. So I have dy dx times 2y minus x equals y. And then I'm going to divide both sides by the 2y minus x, and I have what they're trying to get me to show, I believe, right? So I have dy dx is equal to y over 2y minus x. So let's check. That is, in fact, what they're trying to get us to show, so we have shown it. Okay, so just going back to here, factor out dy dx from both terms.